Today we're going to read and highlight Lesson 2 of the Unit 7 Matter and Energy Student Reader. Scroll all the way down to page 15, which is where the lesson starts. You're going to use the markup tool. I'm going to use yellow because we are marking up on a video versus the projector, so the yellow should be able to come across very nicely on the screen. Whatever I highlight, you should be highlighting in your student reader. Ringing the doorbell. When you go to someone else's house, the first thing you often do is ring the doorbell. A simple push on a small button sends electricity that powers a sound to the inside of the house. This lets people inside know that someone is at the door. Doorbells work because they use a special kind of magnet. Magnets are useful because they can attract or repel, push apart, other objects without touching. All magnets have a north and a south pole. The north pole of one magnet always attracts the south pole of another. However, two north poles will always repel each other, as will two south poles. This is why magnets attract some magnetic objects and repel others. To go to the drawing tool and make sure that you draw a little star over here in the middle. This is some picture that you really need to make sure you know. Kinds of magnets. There are different kinds of magnets. Permanent magnets stay magnetized without electricity. Natural magnets are magnetized rocks. Temporary magnets act like a permanent magnet when they are within a strong magnetic field. They lose their magnetism when magnetic fields go away. Paper clips and iron nails are temporary magnets. Finally, electromagnets are tightly wound coils of wire that produce a magnetic field when electricity passes through the wire. Electromagnets. Electromagnets become magnetized when electricity moves through the wire. This is because electric current produces a magnetic field. Remember that all of the electrons in a conductor move in the same direction as one another. This produces a magnetic field around the wire. A magnetic field is the area around a magnet that attracts or repels other magnets or objects that contain iron or steel. So we are going to highlight the first sentence, and we're going to highlight almost the rest. The magnetic field around a straight wire isn't very strong. However, if the wire is wrapped in a coil, each turn of the coil produces a magnetic field. The magnetic field of each coil combines to create a strong magnetic field when electricity passes through the coil. Electromagnets are useful because the magnet can be turned off by switching the circuit off. It can be turned on by switching the circuit on. And again, we're going to put a star next to this diagram. Something important to remember. Doorbell electromagnets. Electromagnets are the key to how doorbells work. A simple doorbell is part of a circuit. It has a battery and wires. It also has an electromagnet connected to a magnetic clapper. Finally, it has something that makes noise, such as a bell. When you push the doorbell, you close the circuit. This causes electricity to flow through the doorbell system. The flow of electricity creates a magnetic field around the electromagnet. This magnetic field pulls on the magnetic clapper. When the clapper strikes the bell, it makes noise. The movement of the clapper striking the bell also opens the circuit. It stops the flow of electricity. As a result, the electromagnet is no longer magnetized, which is why the sound of the bell stops after a little while. It'll hit it, make noise, and then it stops. Motors. Magnets are a part of many electronic devices because they are used to drive small motors. A motor is a machine that transfers an input of energy into an output of kinetic energy. In electromagnetic motor, electrical energy is converted to kinetic energy. The electromagnetic motor has two parts, an outside permanent magnet and an inside electromagnet. The electromagnet becomes magnetized when it's connected to an electrical current. It then spins rapidly because it is surrounded by a permanent magnet. If a gear is attached to the spinning electromagnet, the gear can be made to do work. We're going to star this diagram as well. So that's the end of lesson 2. Take a minute, make sure you have everything highlighted, and then move on.